In this video, we're going to go over two more theorems and some examples of using these theorems. And so one theorem that we have is the Isosceles triangle theorem, and that says that the angle bisector of the vertex angle in the isosceles triangle is also the perpendicular bisector to the base. And so we see in this example, if we are given that BD is bisecting this angle ABC, and so again, that just means that angle ABD is congruent to angle CBD. If we're given that information, then we can automatically say, well, that means that BD is the perpendicular bisector of AC. And so that just means that BD is coming at a right angle, which we see right here, and it's cutting this in half. And so we get that AD is congruent to DC. And then we also have the converse of that. And so we have that the perpendicular bisector of the base of an isosceles triangle is also the angle bisector of the vertex angle. So if we're given this information down here, that BD is the perpendicular bisector, so forming that right angle, it's cutting this base in half, then we can automatically say that it's also cutting my vertex angle in half. So let's go over some examples of that. So for number one, I am told that BD is the perpendicular bisector of AC. So I see that here, my segment here, BD, it's forming this right angle, so I know it's perpendicular. It's cutting this in half. And I want to find the measure of angle ABD. So I want to find this angle right here. Well, I have to remember what I'm told in my isosceles triangle theorem in Converse, and that told me that if I have a perpendicular bisector here, then I can automatically say that it is also the angle bisector of angle ABC. So that means that these two angles are congruent. So I know that measure of angle ABD is equal to the measure of angle CBD. So I have that 2x plus 5 is equal to 3x minus 12. And now I can just solve from there. So I have subtract 2x from both sides. And I get 5 is equal to x minus 12. Then add 12 to both sides. So I get that 17 is equal to x. Now this question was asked me to find the measure of angle ABD. So now I need to plug my x back in. And so ABD was 2x plus 5, so I have 2 times 17 plus 5. 2 times 17 is 34. And so I get that my answer is 39 degrees. Okay, number 2 says that BD is now the angle bisector of angle ABC, and measure of angle ADB is equal to 12x minus 6 degrees. Find the values of x and y. So now I need to look at, again, what does this theorem tell me? Well, it tells me that if BD is the angle bisector, then it's also the perpendicular bisector of my base. And so that means that I have a right angle here and here, and these two sides are congruent. Now I'm going to first find the measure of angle ADB. And I see over here that ADB is this angle right here. And we know that's a right angle, which is 90 degrees. So that means that 12x minus 6 is equal to 90. Now I can solve for x. And I get that x is equal to 8. Okay, and then we want to find the value of y. Well, I know that these two sides are congruent, so I can set those two expressions equal to one another. So subtract 3y from both sides. And then get negative 15 is equal to 3y minus 45. I'm going to add 45 to both sides. And then divide both sides by 3. And so I get that y is equal to 10. Okay, now let's look at a little bit of a harder one. So this one's asking me to find the measure of angle BAD. So I want to find that angle measure right there. So I need to look at what information I have. I know this angle right here is 6x minus 1. I know this one is 4x minus 9. I need to figure out what I can do with that information. Well, first I see that I do have a perpendicular bisector here, BD, because I see this right angle. I see that it's cutting my base in half. So I do know that that means that it's also the angle bisector of my vertex angle. So I know that these two angles are congruent to each other. So I know that this angle is also 6x minus 1 degrees. And then I know I also have an isosceles triangle because I see that these two sides are congruent. So I also know the angles opposite or across from those congruent sides are also congruent. So I know that this angle is congruent to my angle C. So I can find angle A if I can find angle C. So I need to figure out what equation I can make from this. Well, looking right here, if I cut this triangle in half, I have a right triangle right here. And remember, with right triangles, the converse of my triangle sum theorem is that the two angles that are not the 90-degree angle add up to 90. And so I have that angle C here is 4x minus 9 degrees. I have that angle CBD is 6x minus 1. So I can add up those two. So measure of angle CBD plus measure of angle BCD is equal to 90 degrees. And now I can just plug in what those are. So I have 6x minus 1 plus 4x minus 9 is equal to 90. 6x plus 4x, I get 10x. And then minus 10 is equal to 90. And then divide both sides by 10. And so I get that x is equal to 10. Now I'm almost done. I just need to find the measure of angle BAD. And I know that's equal to the measure of angle BCD. Like we have marked in this diagram. So I just need to plug in x in for 4x minus 9. So I have 4 times 10 minus 9. And so I get 39 degrees.